big reason that we want logarithms is that they allow us to solve exponential equations that are not in that real nice form, where the bases are the same or basically the same. We can use logarithms to solve any exponential equation in this form. There are two rules we need to follow. First, we have only one exponential expression. And second, all variables appear in the exponent. So an example of an equation like this would be this equation, 2 to the 3x minus 5 equals 64. Now, it turns out we can solve this equation in the old way. Why? Because 64 is equal to 2 to the 6th. So we could say 2 to the 3x minus 5 equals 2 to the 6th. And thus, the exponents must be equal. 3x equals 11, so x is 11/3. What's nice about that? We already know the answer to this problem. That means that when we use our new technique, we'll know that our new technique worked. What does the new technique say to do? Well, first we isolate the exponential. In this simple example, that's already done for us, right? This exponential is by itself on one side of the equation. Once we have our equation in the form exponential expression equals number, we can rewrite in terms of logarithms. So in this case, the base stays the same, the exponent and the result switch places. And now we finish solving. And for the moment, I'm going to leave the logarithms sit. I'm going to add 5 to both sides. I'm going to divide both sides by 3. And then I'll get a decimal approximation for x if I want one, and I do in this case. First, I'm going to find the log base 2 of 64. Again, if I have that function, I'll use the log base 2 of 64. Oh, it's 6. I knew that, right? 64 is 2 to the 6th. If I don't have that function, I'll take log 64 divided by log 2. I get 6 either way. Now, in general, this is going to be some awful decimal that I'm not going to want to copy and uncopy. So here's what I'm going to do instead. I want to take this number plus 5 divided by 3. I'm going to put in some parentheses. And now, take a look here on the key with the minus sign. Do you see the little blue ANS above it? That puts in the answer to the last thing I calculated. So I'm going to hit second and then the minus sign to get answer. Plus 5 divided by 3. And I happen to know that this is a nice fraction, 11/3. Let's see an example that we couldn't have solved in the old way. Here's a typical sort of exponential equation that we'll get in applications. 800 times 1/2 to the x divided by 47 equals 20. To solve this equation, first I'll isolate the exponential. I need to get rid of this 800 to do that, so I'll divide both sides by 800. 20 over 800 simplifies to 1/40. Now I'll rewrite in terms of logarithms. The base stays the same, but then the result and the exponent switch places. And now I finish solving normally. I need to get rid of this 47, so I need to multiply both sides by 47. So I'll get x is 47 times the log base 1/2 of 1/40. I want a decimal approximation. I'm going to round this to 3 decimal places. Assuming, of course, the log base a half of a 40th doesn't work out nice. The log base a half of a 40th. No, that doesn't look real nice. If I don't have the log base button, I'm going to take log of a 40th divided by log of a half. Same answer. I want to multiply that by 47. So I'm going to say 47 times answer. 250.131 is a good approximation. I'm going to give you one of these to try. Solve this equation. Round your answer to the nearest whole number. Pause the video and try this now. All right, so we want to isolate the exponential. Divide both sides by 300. I think that simplifies to 70/3. I don't think it's going to simplify any more than that. Now I want to rewrite in terms of logarithms. That means the base stays the same, but then the answer and the exponent switch places. Now I finish solving for t by dividing both sides by 2. So t is going to be the log base 1.08 of 70/3 divided by 2. Depending on my calculator, I'm going to enter that log either as log base 1.08 of 70/3 or log of 70/3 divided by log of 1.08. Neither one of those looks particularly nice, so I'm not going to bother trying to convert it to a fraction. But then to get my x, I want to divide that by 2. So I'm going to say answer divided by 2. 20.46, I want to round to the nearest whole number. T is about 20.